Hey everyone, welcome back to the channel. In today's video, I am going to walk you through how to set up a compiler environment for Ollama, specifically optimized to support the K80 GPU. Alright, the first thing first, we need to install the CUDA Toolkit. For this setup, we are going with CUDA version 11.4. Why? Because it's the latest version, still offer the Tesla K80 support, including a compatible display driver. Personally, I am using Rocky Linux, so I have to choose CentOS. I personally like the RPM install and with network, so it have more compatible with the current system. First, we add a repository. I write all commands into a Docker file, so you probably can use this file to create a build image and compile the source code yourself. And let's start from this one. I'm using Rocky Linux A. The Rocky Linux A have the 8.5 GCC version, and if you're using the Rocky Linux 9, it has a different GCC version. You have to notice the 11.4 or the driver 470 maybe not allow you to using the much newer GCC version. So as the recommend, I using the Rocky Linux A, and laterly I will update the GCC version to 10. I write all commands into a Docker file, so you probably can use this file to create a build image and compile the source code yourself. And let's start from this one. I'm using Rocky Linux A. The Rocky Linux A have the 8.5 GCC version, and if you're using the Rocky Linux 9, it has a different GCC version. You have to notice the 11.4 or the driver 470 maybe not allow you to using the much newer GCC version. So as the recommend, I using the Rocky Linux A, and laterly I will update the GCC version to 10. Not only you're using Docker or your bare metal OS, you always have to doing the update first, and later you have to install the EPEL release. We still need to using the Red Hat or CentOS package. Then we add the repository as the NVIDIA document set, and later you have to issue this command dnf -y and the module install this one, NVIDIA driver 470 DKMS. And after issue this command, you can install the CUDA 11-4, and this command also will install a display driver, which is driver 470 for you, so you don't need to install the display driver again. Okay, And after that, you have to go to the post install step. When I first doing the compiler, I missing this one. It costs a lot of time to debug what happened. Actually, this one is a path to the CUDA binary and to the CUDA library. So we have to add this file or this environment variable to your system. For example, in the Rocky Linux, you have to copy this file, create this file to the etc profile.d, and the system will load the shell script when you log in. For example, you log in as a root, a user, and it will apply this shell script while you log in. This is a global setup. Here we can see this one is CUDA installation guide, and from the left hand side you can find our post install tab. So in this section, it will describe why and how to do the environment setup. Okay, you have to modify the folder path for yourself. In our example, we will need to change it to 11.4. And after that, the CUDA Toolkit setup is complete. And this one is the best I have seen in the internet, created by Benjamin from 2018. Despite the version is different and the OS is different, it still works. So first of all, you have to go to the GCC mirror, get your GCC 10 source. The most important part is this one: contribute, download, pre-require. So when you compile a GCC from source, you need some required library to doing that. It provides a script to download all required library, so you do not need to download it manually. It will have a bunch. If download one, and it will lead another one dependency. And by the way, you do not need to remove your current GCC. So for example, I have the GCC version 8.5 and I want to install the GCC 10. I still need to using the GCC 8.5 to compile the source code. Okay, so after you enter the source code folder, you have to issue this command, contribute and download, and it will download the required library. Then you can create another folder to using as a build folder. The second thing you have to aware is the disable multi-lab. This one, when you're using the configure file, you have to issue this one, and you will not pop out some error. Then you can doing the make and make install. And important thing is the post install. Same thing like the NVCC. NVIDIA CUDA Toolkit. It still need a library link to this one. You have to put your LD library path to the correct folder, and it will make it link to the library. Otherwise, for example, if you're using the 8.5 GCC or 10.3 GCC in Fedora, it will lead a compiler error while you compile CMake or Ollama. It will show something like standard C++ requires some glibc version 3.26 is not exist, something like that. So the main purpose we update the GCC version is to build the new glibc support. Okay, let's go back to the GitHub. Here is the command to install GCC. So first we need to install wget, unzip, and ldzip too. These three is required while doing following command. If you doing it manually, you can find out in the instruction when it lacks some package. Okay, here is the current GCC file, GCC10 file. Where is it? So here you can see I use this command contribute and then download pre-required, something like this one. And this one is the configure command, disable multi-live. If you do not issue this option, and then it will pop out a message tell you the 32-bit support whatever, or warning requires something else. Since we do not need to support 32-bit anymore, you can just disable it. And this one make -J, so you can doing the parallel compile. And this one is the path. I added the path to the to folder. Actually, this is this one. You can see add the USR local live 64. The GCC will put some library here. Okay, here is the install GCC part. Finally, we're going to install CMake and Go. The reason we have to install CMake is the Rocky Linux 8 CMake version is too old, and we have to install it from the source. You can see I put this LD library path here, at least because the Docker environment things not read the profile, so I have to force the environment variable here. We also need open SSL library, so I put the DNF-y here. Here is the CMake source file. It's very straightforward to doing the install. It's almost same as a GCC. Create a build folder for CMake 4 and doing the configure in the folder and then make install. Okay, and then finally This one is Go, and we have to install Golang. And it's the same reason to the CMake. The version is too old in the Rocky Linux A. So in this time I using the Linux binary. So we just extract from the tar file and add the path to the folder. Okay, this is all step to install the pre-requirements. After you doing that, you be able to compile Ollama 3.7. I have pushed the Ollama 3.7 builder to Docker Hub. You can using this repository to compile your Ollama, and it has 7.38 gigabyte, and after extract it close to 20 gigabyte, very large image. Okay, here is the command I use, and it's actually in the GitHub. Here is today's demo. Thanks for your watching. Thank you. I realized there may be something problem in the link or library, so I specify the CC and the C variable here, and it will doing okay. So you can see I using this one, CMake -b, and CMake -build to build the file. Okay, and building the binary here. This one is for building source code. It will take a lot of time. For my setup, I will need about 2 hours to compile the binary, and you can do it yourself. It's fun, and you can let computer running. So, and this one is building the runtime image. So in the runtime, I can using the Rack-Linux 9 with no problem, and copy the binary from our builder. And this one is set our environment just like the Ollama Docker file. I just copy from the official Ollama Docker file. I set out the environment here. The difference is we support the compute capability 3.7 and nothing else different. So here is the Docker file to build Ollama 3.7, and using this Docker file you can running the Ollama 3.7 in the Docker, and you also have to install the NVIDIA container runtime and install your display driver for your Tesla K80. But you can manage the Ollama 3.7 in the Docker. It's more convenient to doing in your bare metal. Okay. Oh, this is today's demo, and thank you for watching.